So in this video, we're going to talk about expected value. Expected value is kind of exactly what it sounds like, and it helps us answer questions like this. How much would you be willing to pay to play this game? So like spin the spinner, and maybe you win $1, maybe you win $5, maybe you win $20. How much would you pay to play this game? Would you pay $5? Would you pay $10? Would you pay, obviously you'd pay no dollars, but how much would you be willing to pay? So this applies to many situations like the lottery or casino games or things like that as well, or even in business strategies. So expected value is basically like coming up with a weighted average. So rather than averaging everything equally, what if I want to give certain outcomes different weights? And so basically all you have to do to calculate the expected value is you multiply each possible outcome by its probability. Then you just add everything together, and that's the expected value. That's the value you would expect to get in the long run. Like if I played this game over and over and over again, its expected value would be the amount that I expect to win. Which in this case, it's actually all equal. I have a 1/3 chance of getting $1. I have a 1/3 chance of getting $5, and I have a 1/3 chance of getting $20. This is actually not a very good expected value example because they're all weighted the same, but it'll give you the idea. If you add all this up, you do that real quick. So 1/3 plus 5/3 plus 20/3. The expected value of this game is $8.66. I just added all this up. So like if I played this game many times on average, I would make $8.66. So it would be a good idea for me to maybe pay $5 to play this game. But it would not be a good idea for me to pay anything over this, like $10. Or if I'm running this game.
Mr. Ian student here.
Okay, you can send him down. You can send him down, thank you.
Okay, the one from yesterday.
Yeah. All right, let's try another example. So imagine you've got a horse called Soon to Be Glue, and the probability that he comes in first place is 1 out of 20. He also has a 1 out of 10 probability of coming in second place, and a 1/4 probability of coming in third place. So you see how they have different probabilities for different outcomes. If he wins first place, it's $4,500. Here's what you win for second place, and here's what you win for third place. So is it worth it to enter the race if it costs $1,000? So there's really two ways you can do this. One way is, let's just find the expected value of your winnings. So take each outcome, which would be the $4,500 for first place, the $3,500 for second place, and the $1,500 for third place, and multiply them by their probabilities. So the chance of getting first place was 1 out of 20. The chance of getting second place was 1 in 10. And third place is 1 out of 4. And then just add those up, and that would be my expected winnings. So let me do that real quick. 4,500 out of 20 plus 500 divided by 10 plus 1,500 divided by 4. And so you would expect to win, just let me see how to make it a video. You would expect to win $950. That is your expected value, because this is only a 20th of a probability that you're going to win that, or a 10th of a probability that you're going to win this. So it would not be worthwhile to enter this contest, which costs $1,000, because I'm only really expecting to make $950 overall. So I probably shouldn't pay $1,000. There's another way you can do this. Why don't we go ahead and take the $1,000 into account? So my outcomes would be, if I win $4,500, I actually had to pay $1,000 to enter. So really, I'm only gonna be making $3,500. And for second place, if I win $3,500 but I had to pay $1,000, then I'm really only making $2,500. And so that's a 20th chance, this is a 10th of a chance, and this one is a 4th of a chance, but this one you would only be making $500. And then there's actually one more outcome that we really need to take into account. And that outcome is, what if you don't win any of these? What if you don't win first, second, or third place? In that case, you lose your money. And so in that case, you're actually going to be making negative $1,000. And the probability of that happening is basically everything else. So if I do a 20th plus a 10th plus a 4th, let me do that real quick. You get 0.4 or 2/5. All of this added together is 2/5. So that leaves 3/5 of a chance that you actually don't win anything and you lose your money. So this is going to calculate the expected value overall. When we talk about expected value, we usually mean this second scenario. It's the expected value of what you expect to win if you paid your $1,000 and you entered the contest. This is what you expect to get out, and it's probably going to be negative. So let me type that in real quick. Don't forget to make that negative, and so the expected value is actually negative 50. That's really close to 0, but that means you expect to make an average of negative $50 if you enter this contest. So again, it's just weighted averages. Instead of them all having equal probabilities of happening, this one is way less probable to happen than this one or this one. Alright, here's another example. A detective figures he has a 1 in 9 chance of recovering stolen property, but his out-of-pocket expenses for the investigation are $9,000. So if he's only paid his fee if he recovers the stolen property. So he's only gonna make the $9,000. Oh, sorry. What is his fee? Oh, the question is, what should he charge for his fee? So let's say he does not recover the stolen property. If he does not recover the stolen property, that means he's going to lose $900 because that was his out-of-pocket expenses for the investigation. The other outcome is that he does recover the property, and that we don't know what we're going to charge for that yet. That's kind of like question mark. What should I charge for that? The probability that he does recover it is set as 1 in 9. So the probability that he doesn't recover it is 8 out of 9. We want to add these up, and he ultimately wants to break even, which means he wants his expected value to be 0. So basically, what do I need to go here to make this equal 0? And you could solve it with just algebra. I'm going to make that an x. So x over 9 plus 8 ninths times negative 9,000 is negative 8,000. And then I'll add 8,000 to both sides. And then do times 9. It's going to be a pretty expensive fee here. So that's going to be $72,000 that he should charge for his fee. It's a lot to pay this detective here. Alright, we're going to skip that one. I do want to mention one final thing, which is a fair game. A fair game is when the expected value of that game is 0. So like the cost of playing the game equals your expected winnings, so that the net value of the game is 0. For example, you pay $1 to play a game, and if you roll a die and get a 1, you win $5. So there's a 1 in 6 chance you'll win that $5, but there's a 5 in 6 chance that you're gonna lose $1. And I guess we're assuming you get your $1 back if you win, but So if you add those together, you get 0, and so that's considered a fair game. If you calculate the probability of any sort of lottery ticket or any sort of casino game, they are not fair games. The expected value is always going to be negative because they've calculated this stuff and they know that overall, sure, they're going to have to pay some people some prize money every now and then, but overall, they're going to be making money, and they've calculated the expected value, and so they know that they're going to be making money. This is actually how your class grades are calculated. It's a weighted average, just like expected value. So you take your standards mastery grades times 70%, and you do your formative grades times 30%. So like, let's say you have an average of 85 on all the tests, and you have an average of like a 90 on all the classwork, all the formatives, then you would just do 0.7 times this plus 0.3 times this, and it's going to weight your test grades more heavily. So if you ever wanted to know how to calculate that, there you go. In this case, you would have an 86.5. By the way, regular averages are technically expected value as well. Like, if I just wanted to find the average of these 4 movie theater prices, I would just add them up and divide by 4. If I wanted to do it the expected value way, you would take each outcome and multiply it by its probability, which in this case is just a 4th for each one, which is literally the same as what we did by dividing it by 4. So you'd get the same thing either